All right, we'll get started. We've got a pretty intense agenda and limited time. So thank you all for participating in the symposium. We've really got a great turnout. I'm Madhu Khanna. I'm a professor in the Department of Agriculture Consumer Economics and also co-director of the Center for Economics and Sustainability that is organizing this event from the University of Illinois side. And then I'm the interim director for the Institute for Sustainability, Energy, and Environment on campus. It's been a real pleasure to be able to co-organize this together with Dr. Shunsuke Managi from Kyushu University, with the goal of exploring opportunities for collaboration between environmental economists at our two institutions. For today's symposium, we have identified four environmental economists at each of our institutions that have research interests that are closely related. And we will be having lightning talks from each of us, followed by time for question and answers, and also discussing next steps to continue this collaboration. The four faculty that are from Illinois that are part of the program today are members of the Center for Economics and Sustainability that is housed in the Department of Agricultural and Consumer Economics at the University of Illinois. And the main focus of our center is to study the problems of environmental sustainability from an economic lens. I would now like to invite Dr. Susan Martinez, who's the Vice Chancellor for Research and Innovation at the University of Illinois, to give some opening remarks. Among her many responsibilities on campus, Dr. Martinez facilitates campus-wide research initiatives and creative collaborations and administers the cross-campus interdisciplinary research institutes. So Susan, please go ahead.
Thank you, Professor Khanna. And I know how packed your schedule is, so I'll be short. But I want to thank everyone today for joining us for the third in a series of conversations around potential research collaborations between our two universities as we consider environmental economics. It's such a pleasure, really a thrill, to kick off discussions like this one. And that is especially true when I'm welcoming such long-standing collaborators like Kyushu University. Given the respective strengths of our great institutions and our research teams, I know that we will find and identify some exciting synergies. And that'll be, a great path forward. This is a topic that covers significant ground, from reducing carbon dioxide emissions, ride-sharing policies, and renewable energy markets to fertilizer use and agricultural practices. With topics of such diversity, I know we will see ample opportunity to work together to address the challenges of sustainability and prosperity for people around the world. Thank you again for joining us today. And while I won't be able to stay for the program, I'm looking forward to hearing about the outcomes of today's discussions. Thank you very much.
Thanks, Susan. Let me now turn it over to my co-organizer, Dr. Managi, for his opening remarks and introductions.
Thank you, Madhu. I'm Shunsuke Managi. I'm the professor, also the assistant to the president on the issue for sustainability. We have been talking on this collaboration between the two universities for the topic on environmental economics. So we have chosen 8 people for a wide range of the topic on environmental economics related to the energy, transportation, and sustainabilities. I think this is a good opportunity to start talking different topics, techniques, and then the next issues. The opening remark will be our Executive Vice President, Toshiyuki Kono. He's responsible for the international affairs for finding the new unique topic for the collaboration between the different universities. Professor Kono, please.
Thank you very much for your kind introduction, Dr. Managi. Good morning, good evening, and nice to see you again. And my name is Toshiyuki Kono, Executive Vice President for International Affairs at Kyushu University. It is my great pleasure to offer a few words at the third event for Kyushu, Illinois Strategic Partnership Colloquia series. I'm very pleased that we are about to discuss one of the most critical issues for our planet, environmental economics. At the virtual climate summit hosted by US President Joe Biden last month. President Biden said the United States sets out on the road to cut greenhouse gases in half by the end of this decade. Also, he promised to build an economy that's not only more prosperous, but healthier, fairer, and cleaner for the entire planet. Japanese Prime Minister also announced that the new goal. Mr. Suga, the Japanese Prime Minister, said Japan's original target was a 26% reduction from 2013. However, he pledged to cut Japan's emission by 46% from the country's 2013 level by year 2030. The two countries agreed to work toward a bilateral climate partnership. I am very pleased and excited that Illinois and Kyushu are organizing today's symposium to address our ground challenges. Last but not least, I'd like to extend my warm thanks to Professor Mandu Kana and Professor Shunsuke Managi for spending their time and effort in preparing for this event. I hope you enjoy every aspect of this event. I tried to stay as long as possible today. Thank you.
Thanks, Dr. Kono. Shunsuke, would you like to introduce our first speaker from Kyushu?
Sure. First speaker from our side will be the Sunbin Yu. She's an assistant professor in the Urban Institute of the Kyushu University. She'll be talking on the issue for transportations. Sunbin, please.
Thank you so much, and good morning, everyone. I'm very honored to be a first speaker of this event. And I'd like to share my slides. Can I? Sorry for that, just technical issues. So let me just begin with my keywords. So with our transportation in East Asia, and I'm basically looking into the consumer sides. So the reason I focus on transportation is because it needs a broad and interdisciplinary solutions, for example, like economics, engineering, and even natural sciences. And the reason why I focus on East Asia, for example, my researches are mainly focused on like Japan, like city level, like Tokyo, Shanghai, or Seoul, which are a mega city, but with a lot of like a number of populations inside. And actually they are developing, the transportations are in these cities are developing rapidly, while they're also a big contributor of emissions from vehicles. And that's why I also look into the consumer side, because I wonder whether people's behavior regarding, for example, like choosing what car to buy or how to drive would contribute a lot for the emissions. So this is my research title, a preference for technology evidence from the automobile industry. And I actually, this is a co-authors. I have co-authors from University of Tokyo, who are Naoki Wakamori and Yoshikuni Yoshida, those are the professors of economics and engineering, respectively. And this paper has been accepted to Transportation Research Part D, Transportation Environment, recently. So let me go over with my research objective and the backgrounds. So the problem, I found a problematic, or as a motivation of my research, is that, first of all, in panel A, which is in the left side, we can see that from 2006 and 2016, both average fuel economy and sales weighted average fuel economy of the newly produced vehicles in Japan has been increased rapidly, while there is they have increased 40% during 10 years. And we also see the gap between sales weighted average for economy, which is a red line, and the simple average for economy, which is a blue line. That's that. And the problem we see here is that in the panel B, regardless of the increase of the sales weighted and also the simple average for economy level, we see this emissions has been decreased only for 4%. And actually the decreasing pattern of the emissions is quite symmetric, I'll say. For example, from 2009 to 12, it has been decreased a bit rapidly, while in panel A, the fuel economy also has been increased rapidly as well. So we think there is a pattern between fuel economy and emissions. Therefore, the vehicle emissions should be explained with consumer preferences, like which is a vehicle purchasing behavior, and also with the technological advancement, which increases the simple average level of your economy. So basically, I'd like to answer the two questions. First, whether consumer preferences toward pure economy has changed over time, and whether those like consumer behaviors have implications for CO2 emissions. Basic contribution of this research is basically we look into technology and consumer preferences in the same time and decompose these two in terms of emissions. So while there are a lot of researchers actually looking into the vehicle choice model and emissions in the previous researches, which are from the famous journals, while these researchers are likely to look into the either side, for example, the consumer preferences or technological advancements, or endogeneizing technological advancements with pure consumer preferences. So basically, we want to decompose the two in terms of the emissions. So we have this data of 2006 to 16. Well, I'm just showing the data from 2006, 10, and 16, but we have like 10-year data. And we have a vehicle attributes of, for example, like price and how the units sold. Basically, this is monthly data of the models has been sold at that month. And fuel economy, displacement, horsepower, weight, and car length, which are basically the vehicle attributes, which are used in the standard vehicle choice model. And we estimate the utility of consumer I choosing car J in year T, which is expressed in this equation number 1. So we estimate the indirect utility UIJT, which is the level of utility the consumer gets by choosing automobile J in year T. And we have a equation here, and actually, let me just read out. So XJT stands for the vector of unobserved vehicle attribute, observed vehicle attribute, for example, like weights, like displacement. PJT stands for the price, and we have this psi term here, which is the one of the characteristics or benefit of using this model, which is the unobserved attribute by econometricians. For example, like people have different preferences towards, like, for example, let's say color or the services, or they just have individual preferences for a certain car. We estimate that heterogeneity in this model by using the BLP technique that I'll explain later. We have other term EIJT and alpha, which is a price coefficient, which is usually most likely be negative. And beta IT, which is a vector of the coefficients of the vehicle attribute, which depends over time. I'm going to explain this to you later. So this is our result here. So I like to focus on model number 7 here, which is a finalized model. We have 7 models with different specifications, but basically they are quite similar in terms of interpretations. So we have this 0.8 for the fuel economy of year 2010, while we also see the fuel economy from 2006 from 9 has been decreasing over time, and from 2011 to 16, the fuel economy level decreases over time as well. So we see that from 2010 to 2016, the fuel economy preferences of Japanese consumers has been decreased. So what we do here is a bit an interesting exercise. We conduct a counterfactual simulation here. So we actually have 4, 5, 6 scenarios, but in this presentation, I only present 2. In scenario 1, what we see from this result was that people in 2010 prefer cars with higher fuel economy compared to the people in 2016. That having said that, so we have consumers from 2010, which prefer high level of fuel economy. We give them a choice set of cars from 2016, which have a high fuel economy, a higher level of fuel economy compared to the year 2010. In scenario 2, we do the opposite. We have consumers from 2016, which do not prefer high fuel economy compared to 2010. And then we give them a choice set of cars from 2010, which has lower level of fuel economy. We want to see whether they purchase cars which has lower fuel economy compared to 2016. It's a bit confusing, but this is a result from my counterfactual simulation here. Let me explain this a bit like step by step. By scenario 1, we have consumers which prefer high level of fuel economy, and then we give them a cars with high level of fuel economy. And then what we see here is the number of aggregate sales has been increased around by 5%, while the average fuel economy has been improved by around 3%. But then we see the overall emissions would increase by the vehicle fleet, of course, has been increased by around 3.7%. So even though we have a high level of fuel economy, if the consumers prefer, of course, high fuel economy, then they will purchase more cars, will replace their cars and drive more, which actually results in increases in emissions. In scenario 2, we have opposite. For example, we have the consumers who not prefer high fuel economy, and we give them cars with lower level of fuel economy, low level of fuel economy compared to 2016, which actually leading to this decrease in sales by 3%, because they would not just for example, like consumers in 2016, they don't really even though their preference level has been decreased, does not necessarily mean their overall preference level is becoming negative. So basically they prefer the cars with, like, for example, like a good level of fuel economy, so they don't really buy the cars. And then the thing is, because the choice set of the entire choice set, the level of fuel economy has been decreased, the fuel economy would decrease by 2%, which links to emission decrease by 2.3%. So it seems like, for our understanding, well, actually, this is my conclusion on my research. So basically, this technological innovation, for example, like fuel economy level of choice set, and the consumer preferences are actually very important. Like both of them are quite important when it comes to understanding the emissions from vehicle fleets. So that's it, and thank you for listening.
Thank you, Sunbin. Shall we move to the next, Madhu?
Sorry, it was muted. Thanks. All right, we'll save question and answers to our mid break time and move on to our first speaker from Illinois, Peter Christensen, who's an assistant professor in the department. And he's going to be talking about how economists can use ride-hailing markets to inform optimal transport policy. Peter?
Thanks, Madhu, and thanks everyone for having me today. It's really a pleasure to see all of this great research and be able to have this kind of interaction from afar now, maybe someday closer. So today I'm going to give you a broad overview of a research agenda. I'm going to talk about some results, but I'm not going to get into the specifics of analysis in any of the papers that I'm going to be presenting, but I will point you to them if you're interested in taking a closer look. Before I do that, just a little bit about myself. I run a research team here at UIUC that brings economists together with computer scientists to do environmental economics research that's particularly focused on the intersection of urban and environmental policy. So I think there's a lot of overlap with others who are here today, and that's really wonderful to see. So just a little bit of motivation for the talk today. Urbanization, as many may be aware, is a 21st century sustainability challenge. The UN expects that more than 2 billion people are going to be moving into cities in the next couple of decades. And of course, at the same time, in those next couple of decades, we are making very significant attempts to reduce greenhouse gas emissions. The outcomes, the economic outcomes of this process is going to depend in large part on how policymakers manage growing demand for infrastructure and urban public goods, including transportation. And we just saw some research that is focused on the importance of consumer preferences in terms of vehicle purchases. I'm going to be speaking about consumer preferences and demand for different types of transportation services. These things are very related and all very important for understanding greenhouse gas emissions trajectories, particularly in the developed country cities, but also in developing country cities. Emissions trajectories are largely, many believe that emissions trajectories will largely depend on whether transport patterns crystallize around private versus shared transportation. And so that's a key research question that underlies some of the work that I'm going to be talking about today. Ride-hailing services. So what can we learn about from ride-hailing markets about transportation policy? So of course, there is a lot of interest in this new set of services and emerging markets. They've changed transport. Many argue that they've changed transportation markets, particularly the option sets, at least, of residents in cities around the world. And many of us may be familiar with a couple of the top 10 firms, but really there are now tens of and more firms that are operating in particular cities and competing with the firms that we might be aware of. How do we think about what the disruption of ride-hailing markets in the transportation sector? Well, we tend to think about this as a matching technology, services that are reducing matching frictions, the first generation being taxi services, but now with additional types of services, shared transport services, van pools, bus services, et cetera, emerging. And many are beginning to envision a world where these matching technologies are potentially playing a role in multimodal transport that involves private vehicles, mass transit system, and everything in between. Of course, many are concerned, policymakers as well as environmental economists are concerned that while ride-hailing services may increase public transportation as a complement, they also may reduce it as a substitute, right? And so this is a key question that some have been looking at, particularly particularly in relationship to understanding the potential effects of ride-hailing markets, specifically on transport emissions. We need to be thinking about how demand for transport may interact with these technological changes. And in the developing country city context, it's likely that ride-hailing services are making personalized transport more accessible, particularly in places where car ownership has high fixed costs relative to incomes. And finally, relative to existing taxi services and sometimes public transit services, they provide additional safety through accountability mechanisms. So these are some of the underlying factors that are affecting transport markets through the emergence of and maturation of these sectors. Now, importantly for us, engineering estimates suggest that autonomous vehicles technologies could bring down the costs of ride-hailing services by 50 to 85% over the next couple of decades. Now, I'm going to talk a little bit in the next few slides about opportunities for using ride-hailing services in these markets for transport policy research. Here we're focused on the challenges not just of transport itself, but doing research on transport markets. We know, those of us who are working on these questions, that empirical and measurement challenges have limited our ability to study the effects of both technological and policy changes in transport markets, in part because transport policies are almost never randomly assigned. So we're thinking about endogeneity issues here, Only observing responses, which we typically do on a single mode, doesn't tell us enough about overall effects. Data on total mobility, which we would like to have in thinking about the effects of a price change on transport behavior at the individual level, are extremely rare. And so it's our view that experiments with ride-hailing services and when paired with careful data collection can help overcome some of these challenges. In particular, carefully designed experiments can help us tackle some very big policy questions, including identifying and helping policymakers identify transit deserts to make evidence-based investments in public transit, understanding the effects of increased urban mobility on labor market and other types of economic outcomes, understanding the optimal regulatory tools for shifting incentives and restructuring incentives to encourage public transit ridership, pooled travel, and electrification. And I'm going to just share very briefly the results from a recent experiment, which you can find on my website. It's now a working paper called The Demand for Mobility, Evidence from an Experiment with Uber Riders, where we ran an experiment in collaboration with Uber Technologies with over 1,300 Uber riders in Cairo, Egypt. Uber, the way that this was designed, Uber sent messages to a random set of active riders, inviting them to join a study on mobility patterns. Interested riders clicked a message and signed up. We then called them to implement a baseline survey and begin to measure their total travel using their Google timeline, so on their mobile device. And then eligible individuals are assigned to a cohort and randomized into 3 groups. One that receives a 50% price reduction in Uber services for 3 months, another that receives 25% price reduction for 3 months, and a third control. And then we continue to collect follow-up data, both on total mobility, Uber utilization, and other outside economic outcomes. The primary findings from this study: latent demand for mobility, at least in Cairo, is much higher than current estimates would suggest, multiples higher. And in part, we think that this is due to the combination of unique features of the ride-hailing market, limited outside options in a city like Cairo, and our ability to run an experiment, which we're comparing to a lot of quasi-experimental evidence that exists. Reductions further in prices translate into large effects in overall mobility. We find that safety matters, that our mobility effects are partially driven in Cairo by women who feel unsafe on public transit, who are substituting away from the bus system into Uber services when prices go down. This suggests that large price reductions that might be technology induced could have large effects on congestion and emissions externalities, as well as yielding some large benefits. We estimate that the social benefits at the city level from a 50% price reduction are on the order of $2 billion annual purchasing power parity dollars. But the external costs are also very high, approximately 2/3 of the benefits. Finally, we use a structural approach that is similar to the talk that we just saw to estimate the benefits and simulate the benefits of increasing safety in public buses. And we find that investments in safe public transit would yield even larger benefits than a 50% reduction in Uber services. In particular, a policy that leaves no passenger feeling unsafe in Cairo's public transit system would yield almost $5 billion annual purchasing power parity dollars in benefits. Just very quickly, there's a broader agenda here. Again, as I explained before, and hopefully I've convinced you, there's a belief that well-designed experiments with data on total mobility can help us design better policy. So we're currently building a system at the National Center for Supercomputing Applications here whereby subjects can directly share anonymized trip level data from their mobile phones. That's allowing us to run a second planned study that's focused on the potential for subsidies in ride-hailing services specifically for transit-linked trips to and from metro systems to address the last mile problem and increase public transit ridership. And finally, we have just proposed a study to focus on the barriers, understanding the barriers to multiple occupancy transport, which, as I suggested at the outset, many believe is going to make the difference in terms of emissions growth as transportation demand increases, particularly in the developing world over the next couple of decades. Thanks so much.
Thanks, Peter. I'll turn it back to you, Shunsuke.
Yep. Thank you, Peter. Next will be Alex Kyushu. Alex is an assistant professor of Urban Institute. Alex, please.
Thank you for the introduction, Professor Managi. My name is Alexander Tekili. My current position is an assistant professor at Kyushu University, Department of Civil Engineering. And before my current appointment, I worked at international organizations, including IEA, UNDP, and the World Bank. And I also founded a renewable energy company to introduce mini hydro energy in my hometown, Fukuoka, where Kyushu University is located. And talking about renewable energy, today I'd like to make a presentation on titled Renewable Energy and Energy Market, Supply Impact and Demand Change. And in this talk, I'm covering two analyses that we have conducted recently. So because of the time constraints, I'll only talk about the key points. But the first one is on the left side. We're focusing on German market, which is one of the leading countries in terms of renewable energy development. And we're looking at the supply impact of renewable energy on wholesale electricity market price. And second analysis on the right side, we're focusing on Japan. Japan is also unique in terms of, in the sense that renewable energy development is mostly led by mega solar PV. And we're focusing on demand side, the impact of increasing renewable energy on consumer demand, measured through willingness to pay. So moving on to the first analysis, the supply impact of renewable energy on wholesale electricity market. So when renewable energy penetrates wholesale electricity market, it tends to reduce the market price, which is called merit order effect. I'd like to explain briefly about this a little bit more. So in the electricity market, usually the cheapest ones in this order: renewable energy, nuclear, lignite, hard coal, natural gas, fuel oil. The cheapest one in terms of marginal costs are used in priority, and this is called the merit order. So assuming that there's a power market with three technologies, including nuclear, gas, and oil, this is a supply curve with three technologies and demand curve. And the price is determined here, 90 cents per megawatt hour. But when renewable energy penetrates the market, because renewable energy is marginal cost, it's very cheap, it's the lowest one. This will shift the supply curve to the right. And as a result, the price will decrease. And this price decrease is called merit order effect. So the main objective of the study was to investigate how much quantify the merit order effect. In order to do so, we have focused on German and Austria power market, which is the largest market in traded volume during the period from 2010 to 2017. We have used hourly data for spot market price and load data and generation data from wind and solar PV. And also to control for systematic prices changes, we introduce time variables, time dummies variables. And using machine learning to be specific extreme gradient boosting method and GLS, we conducted an analysis. Jumping into the, a little bit more information on data. Some of the notable points are that standard deviation of price is pretty high compared to others. And mean value of wind is double that of solar PV. Skipping the details, and again, the objective of this research was to quantify the merit order effect, and also to investigate the differences in merit order effect between solar PV and wind energy, and how they differ across different hours in a day. Jumping into the results and the highlights. First, about the merit order effect, quantifying the merit order effect, how much the renewable energy has decreased the market price. So electricity from wind and solar sources reduced spot market price in Germany and Austria by around 10 cents per megawatt hour on an average for the past during the period 2010 to 2017, which is a quite large price decrease. And another notable point, none of the paper has looked at this issue from this perspective. We investigated how they differ in each hour. And as the table show, wind had relatively stable impact across the day because wind is blowing mostly throughout the day, ranging from around 6 to 8 cents per megawatt hour, while the solar energy impact varied greatly across different hours, ranging from 0.2 to 12 cents per megawatt hour. And looking at here, especially from around 11 o'clock to 1 o'clock, the merit order effect is stronger than wind. So it is really important to look at not only average merit order effect, but also to have a deeper understanding on the impact on electricity market. We need to look at how it differs for each time. And another notable point we found through machine learning analysis is that through these figures called partial dimension plots, we identified interesting characteristics of the interaction between renewable energy and spot market prices. This is the spot market price and wind generation and solar generation. And we can see that the merit order effect diminishes as there's more wind generation. So the more generation comes from wind, the more generation comes from solar, the merit order effect actually diminishes. These kind of non-linear interactions have not been shown in papers. So this is one of the features that we can do through using machine learning. Moving into the next analysis. This one, we look at the demand side. First one, we looked at supply side. This one, we look at demand side. The impact on consumer demand measured through willingness to pay. Brief background information. Especially since the introduction of the new feed-in tariff system in 2012, a large-scale solar PV installation have been rapidly increasing in number and capacity. And because of the construction of solar PV power station, disregarding regional characteristic, damage to the landscape, a negative image of solar power generation is starting to take root in Japan. And scholars are arguing that NIMBY phenomenon, not in my backyard phenomenon, is happening for renewable energy too. So this was also one of our key point that we wanted to investigate, whether NIMBY problem is actually happening in Japan. How we did that? So the analysis of determinants of social acceptance toward renewable energy in Japan. We use willingness to pay survey data on social acceptance toward renewable energy, which includes solar PV, wind, and mini hydro energy. And we included various GIS data, including the distance between the power generation facilities and respondents' locations, and the surrounding artificial and natural environment, and most importantly, visibility of power plants. So based on the satellite information, we classify solar PV power plants, all of the solar PV power plants in Japan, to the visible ones and less visible ones. And we saw we try to show the impact of visibility. That's why the subtitle is the value of invisibility. And jumping into the results and discussion, the table shows that for all of the renewable energy technologies, solar PV, wind, and mini hydro energy, subjective well-being and human capital, which is measured through salary, age, and education level, and surrounding natural capital and existence of power plants, they all have significant statistical significant impact on social acceptance. And especially focusing on solar energy, solar PV, the existence of NIMBY phenomenon and the value of invisibility was identified. I would like to talk about this point a little bit more. About the NIMBY phenomenon, from our results, the existence of solar PV power plants located nearby within 3 kilometers from the respondents' location. They significantly influence social acceptance towards solar PV, negatively and significantly. However, solar PV located within 3 to 5 kilometers, they didn't show any statistical significant impact on WTP. So this shows that existence of NIMBY phenomena for solar PV in Japan, but no significant impact observed in the case of wind and mini-hydro energy, partly maybe because wind and mini-hydro is still less developed in Japan. And another interesting point was the value of invisibility. So through classifying visible solar power plants and non-visible, less visible power plants, such as placed on roofs of buildings and public facilities, these less visible power plants did not have any influence on social acceptance, while the visible solar PV power plants had significant and strong impact on social acceptance. So this also shows the importance of invisibility. How you place the solar PV renewable technology can have a great impact on society. These are the key points of the two analyses that we have conducted. And as a concluding remark, the impact of renewable energy introduction needs to be investigated from various aspects. For example, impact on the environment, human, economy, etc. And we are now developing a new integrated assessment method, which combines LCA and IO analysis to look at society, environmental, economy impact of energy technologies. And through using this method, just with the cost components data, we can calculate all of these aspects. So I'm very much looking forward to any collaborations in this aspect. And thank you for listening to my presentation.
Thank you, Alex. Madhu, back to you.
Yeah, thanks, Alexander. All right, our next speaker is Hope Michelson, the associate professor in the Department of Ag and Consumer Economics. Hope. And she's going to talk about low fertilizer in sub-Saharan Africa, new insights into an old problem. Oh, sorry, the title's changed from the one in the program.
I did change it. I thought it would be more fun. It's the same topic, but it allows me to get into a bit more detail, which seemed fun with this group. So my name is Hope Michelson. I'm an associate professor in the Department of Ag and Consumer Economics. I'm also a member of CEOS. I'm a development economist. I focus on ag. So I work a lot in East Africa and Central America. And what I'm learning over time is that you cannot think about ag and poverty in low-income countries without trying to think about the environment in some capacity, because it's so fundamental. So my work sort of has begun to crash into environmental work. So it's nice to be with this group. So the problem that I've been working to understand for a while, as have a number of development economists focused on ag, is related to fertilizer use being persistently and problematically low in East Africa. And the reason that we care about this is that you've got a continent and a region in a continent in particular where you have persistent poverty, widespread child stunting, and low agricultural yields. And we know through looking at countries changing over time, and then also looking at what's happening in the cross section, that increasing yields is strongly associated with reductions in poverty, right? So getting the economy going and sort of getting an economy to structurally transform, we know that increasing agricultural productivity is a big part of that. And so, increasing the use of mineral fertilizer is really critical here. But it's really low. So I've looked at this in a couple of different places. So I'm going to talk about two different data collection efforts that we have in this really short talk. And just to give you an example here. So in the Uganda survey, which is about 3,000 small farmers, only 14% had ever used mineral fertilizer, not just in that year. And in Tanzania, 34%. I did some work in another region of Tanzania where we had 2% of farmers had ever used mineral fertilizers. So these are, these are sort of facts that are beliefs about what's happening there that are really borne out in the data when you start talking to small farmers. So there's a really interesting puzzle that we've been thinking about for a couple years, and we stumbled on this when we were working on soil quality testing and sort of information dissemination, which is farmers telling us that the fertilizer was bad. And that part of the reason that they weren't using fertilizer was that it wasn't good quality. So what we hear again and again, and this is something we've done now in 3 or 4 different surveys, and other folks have looked at this, is that about 35% of the fertilizer is counterfeit. So that means that they think that the fertilizer has been mixed with something else, or something that's not fertilizer is being sold as fertilizer. And so we've done some focus group work in Tanzania, a lot of discussing with farmers. We're really worried about this counterfeiting issue, right? So something that's not fertilizer being sold to them as fertilizer. So the interesting thing is, the puzzle is, we've now done more than 1,200 tests of fertilizer, and other folks, especially at so the international body regulating fertilizer quality, have done tons of tests of urea fertilizer, which is the most commonly used fertilizer. It's a pure nitrogen fertilizer among small farmers. And the fertilizer is good, right? It is not bad fertilizer. So these are studies from lots of different countries in East and West Africa, and it's showing you the share that was in compliance, right? So I should say 100% was in compliance. So this is really interesting. So we see that farmers have this persistent belief that they're really worried that it's bad. We have evidence from doing willingness to pay assessments that shows that they're actually willing to pay less for fertilizer when they don't know that it's verified quality, right? Which is the condition that they are constantly operating in rural markets. So sort of asymmetry about fertilizer quality. There's poor regulation. There's a lot of uncertainty about what they're dealing with, and yet we see that it's good. This is pretty conclusive evidence, I think, at this point, that urea fertilizer in particular is good. So what that ended up, so the research ended up changing in the last year or so. So initially we wanted to understand what was the source of these fertilizer quality problems, and what were the effects of bad fertilizer on people's yields. That's not the question anymore. The question I think that's really interesting here is, why does an incorrect belief persist in equilibrium in these markets? So what we've been doing then is trying to investigate that. So I'll, in the last 5 minutes that I have, I'll tell you a little bit about these facts about belief, tell you about the work that we've been doing where we've developed a Bayesian learning model with misattribution and multiple priors. We're simulating that model. This paper's in a review currently. And then we've got some really interesting suggestive evidence that I'll take you through. So just to show you what people believe and the sort of interesting range in what folks believe, this is the same survey in Uganda and Tanzania, with small farmers. Right? So what you see is about 65% in Uganda and about 66% in Tanzania of the fertilizer on average farmers think it's good. But there's a really wide range in what people think, right? And you've got a whole bunch of people that think it's fine, and then you've got sort of a normal distribution of people that think that that there's a problem, right? That belief is relatively normally distributed. But it's really interesting. There's a lot of uncertainty in those beliefs. So in Tanzania, we asked them to tell us how confident they felt in the belief about the share of bags that are good in a market. If 10 farmers went to buy fertilizer, how many of them would be good bags? So we see a big range in what people said about that. And then in Uganda, this IFPRI team whose data we're using actually elicited the distribution, so we can see what the range is in the belief. And it's a pretty significant range in that belief about how good the fertilizer is in the market. So we developed a Bayesian learning model that incorporates 2 features that together explain both how incorrect beliefs can persist in equilibrium after many trials, and also how uncertainty in belief can also remain. So we're building on some ideas in the literature, and then also we're building on insights from these focus groups and all the work that we've done with small farmers. So we're assuming that farmers form beliefs about the likelihood that a bag of fertilizer purchased in their local market is good, so the likelihood that it's counterfeit. And the idea that we have is that there's this, it's hard to detect in terms of misattribution, it's hard to detect quality. It's hard to actually understand what the signal is because you're operating in such a stochastic production environment, right? And so, you could get a bad draw on a yield, and it could be because you've got, rain at the wrong time or rain in the wrong quantity or some other kind of a shock, and it might not have anything to do with the fertilizer itself, but you might misattribute that outcome to the fertilizer quality, right? So this is a really plausible story in the context of the stochastic production environment that characterizes agriculture. So we simulate this model. So the initial simulations that I'm going to show you are just the simulations that are taking a look at this issue of misattribution. So on the left, you're seeing over 100 periods the evolution of beliefs with a uniform prior no misattribution. So you can see under that circumstance, over enough trials, the fertilizer, the belief about the quality of the fertilizer does converge to the truth over time, right? The truth being that the quality is good. If you add misattribution, even over 100 periods of working with the fertilizer, you don't get a convergence to the truth, which is that the fertilizer in the market is good, right? So then, right, in that case, we're just thinking about a single belief for a prior. If we map in multiple priors to try to get at this notion of uncertainty around the beliefs, which we've documented now in a number of different surveys, right, we can see that you actually end up with a circumstance in which the range in the belief actually persists over time. So once you add multiple priors into misattribution in this model, you've got a circumstance in which beliefs fail to converge to the truth, and farmers remain uncertain in their beliefs, even after multiple periods, after over 100 periods, right? So one thing to note, we haven't incorporated social learning into the model that, you know, I think would have some interesting sort of exacerbating tendencies in terms of what we're looking at. So the last thing that I'm going to say is we take the insights from that model and from the simulations, and we think about, you know, do we actually see in data, especially in nationally representative data, where we've got a lot of spatial variation in rainfall, which is the leading contributor, right, the sort of driver of stochasticity in agricultural production, right? So the model suggests that you would have worse beliefs and wider beliefs in circumstances where misattribution is more common, right, and in which outcomes are going to be more variable. So we've got really nice nationally representative data on these beliefs from Uganda that I've already showed you. We can take that data and we can pair it with information about precipitation over time, and we can look at it and see whether or not places that have more variable precipitation are also places where you've got this wider belief range, and also where you've got sort of a worse belief, if that's clear. So we use this Uganda data, which is, as I said, nationally representative and really rich, and 10 years of CHIRPS precipitation data. We can, you know, extend or shorten that range depending on what we think the sort of relevant range is for, you know, kind of the farmer mental model for thinking about production and these stochastic outcomes. And we see this really interesting relationship that you know, the prediction of the model is essentially borne out in the data, right, where you see that the belief, this is that same belief, which ranges between 0 and 1, which is how we list that by asking farmers how many bags would you expect 10 farmers who went to a market to get that were good versus bad, right? So what we see is that in places where you've got you know, more of so we see that the variation is correlated with worse beliefs, right? So this is the belief that it's good. So places where you've got more variability in that precipitation are places where you've got a belief that the fertilizer is worse in the marketplace. And we also, I'm not showing you that here, but we can also show you, I could show you that the range is the same. So if you put the range on the y-axis here, that there's a strong relationship between places with more historical variation in precipitation and a wider range in that belief, right? So, so we've got this puzzle. It's a really interesting puzzle. I think it's an important puzzle. You know, we're seeing that it actually is affecting farmers' willingness to pay. We've got a new randomized control trial where we're randomizing information at the market level about fertilizer quality and looking to see how that affects farmer purchasing to try to sort of get that belief to move. Right? So we see that there's this really interesting problem. We see that farmers are unsure in their beliefs. The model and simulations, and then the sort of existing data that we have that we can use to test model predictions suggest that misattribution is going to be the main driver of increased beliefs. And I think there's this really interesting question ultimately about whether or not fertilizer is actually credence good, right? The idea that you can kind of learn quality over time, it may not be true. So instead of being experience good, fertilizer may in fact be a credence good. And I think there's some really interesting possibilities for the way that this kind of an insight would apply to other kinds of goods and products and potentially to some in the environmental economics space. So thanks very much.
Thanks, Hope. All right, I realize now that we should have asked people to put questions in the chat as they were hearing the speakers, but overlooked to do that. So we do have about 10 minutes for question and answers. Just feel free to unmute yourself or post your question in chat, and be happy to pose it to our four speakers. I guess as you're thinking about these questions, I can start off with a question for Alex, and thanks for your talk. I was curious and sort of interested in this, your finding that the phenomenon of NIMBY applying to solar, particularly ground-mounted solar, and sort of a couple of questions related to that. One is, is that I know that as this ground-mounted solar is increasing, there's a lot of concern about its competition for land with other uses, and looking at how you can have dual use of solar for not only for energy but also for something else. I mean, here in the US, we are looking at whether you can grow crops under solar, and I know there's quite a bit of work on that in Japan. So how much of this do you think is being driven by just concerns about the competition for land versus that it's a visible and maybe not a pleasant site to look out for? And then related to that is that there's also, in Japan, I know there's lots of concern also about nuclear for very obvious reasons. And so, given that both solar and nuclear, if they're not regarded as sources for low carbon energy, then what might be the alternatives that Japan would consider for reducing carbon emissions?
Mm-hmm. Thank you very much, Professor Madhu, for the great questions. Regarding the first question, how much the land use impact could be affecting the willingness to pay of the residents, I think visibility was one of the factors that we were focusing on, but I think also the land use, how much the ground-mounted solar PV impacts the land use, would be affecting WTP2. So not just visibility, but impact on land use is definitely a very, very important factor, I believe. And moving on to the second question, alternative, having solar PV and decreasing nuclear power plants. Japan has declared that we will decrease nuclear power plants and increase renewable energy. And biggest problem in Japan is that we don't have good energy carrier. We don't have fossil fuels enough in Japan, so we need to create energy and store it enough. So one of the key elements, energy carrier, that could be developed in Japan is hydrogen, I believe. And Japan is, this is, I think, a third round. Japan is spending a lot of money on hydrogen. And now Japan is spending very, very much money on hydrogen. So I think one of the keys is a combination between renewable energy and hydrogen, and clean technology and clean way to store it as one of the ways, I believe.
Mm-hmm. Great, thank you.
Thank you.
I also said for the nuclear, for the Madhu race, the current ruling party in Japan tried to put forward for the nuclear power, but this is a matter for stability for the all political confidence, and usually it's not high priority compared to the other COVID and other issues. So they cannot say much on promoting more for the nuclear right now. Mm-hmm. I think there is a hand.
Okay, yeah, thank you, Dr. Managi. So I have a question about the Peter's research. Okay, yeah, thank you very much for your innovative idea. And yeah, I'd like to know about the more in detail about social benefit and the social cost. I think there is several factors: accident, pollution, and safety, so on. So I'm wondering which factor have a highest value of the social cost or social benefit. So could you please explain the composition of the social benefit and social cost?
Yeah, great question. Thank you. So in terms of, the simulation that we ran, and I'm happy to send you the paper as well, so that, because that way you can really get into the details. It's hard to do that in just a few minutes. Okay. But basically the simulation that we ran is focused on the 50% price reduction, the effects of a 50% price reduction on consumer surplus, right? So that's very actually straightforward to estimate directly from the experimental, our experimental estimates. So what is a little bit complicated and what's really actually interesting about thinking about these types of experiments is that what we wind up, whereas the majority of the literature that is used, that's estimating effects of using quasi-experimental variation, where you might have a variation in price at the market level. When we're doing this for, when we're reducing prices for a subpopulation, maybe a small subpopulation, where you know, we're directly estimating a price elasticity of demand, but isolating that, in fact, from the additional congestion effect that you would have given that price, new price in equilibrium, right? So the expectation is that you'd have more people as prices go down on ride-hailing services, right? You'd have more people using them. Of course, that would increase congestion, increase the cost of time, and that has to be incorporated when thinking about, you know, a simulation of a market level change, both in terms of consumer surplus as well as in terms of congestion. So on the congestion side, what we do is we estimate that the market level equilibrium effect, and then we use current estimates from the World Bank on the existing external costs associated with private transportation in Cairo, and we basically shift that by our change in experimentally identified change in the equilibrium on-road traffic, right? So all of that is based on existing estimates that include the accident externalities, local air pollution externalities, and greenhouse gas emissions externalities. And the accident externalities are always the largest, as well as congestion externalities. They're always the largest, and that's been shown in many developing country cities. But of course, you know, we need to understand the relative sizes of these because they have different policy implications. So.
Thank you very much.
Thanks.
Okay, thanks. You know, it's great to see that there is a question answer thing going on in the chat. So please continue that, given the time is limited. And with that, let's move on to our next speaker.
Okay, me?
So, yeah.
Oh, yeah. Next speaker with Hide Fujimi. He's an associate professor at the Kyushu University on the Econ department. Hide, please.
Okay, thank you very much. So can I share my PowerPoint file using chat box?
Please.
Okay, yep. Okay, yeah, I can send my. Okay, yeah, it's restricted. Okay. Anyway. Oops. Okay, can you see my PowerPoint file? Yep.
Yeah.
Okay, yeah, thank you very much for giving me a chance to do the presentation. Okay, today I'd like to talk about the toxic chemical substances management using the toxic release inventory data, the US industry data. My name is Hidemichi Fuji. I'm from Kyushu University, Faculty of Economics. So this is the contents of my presentation. And then the main objective of this presentation is to develop the relationship for research collaboration with researchers. So I said the number 3, so proposal for research collaboration with University of Illinois. Okay, so let me introduce myself quickly. So my research interest is the 3 points. So corporate environmental management and industrial ecology and environmental innovation. So interdisciplinary research fields are related to environment is my research topic. And then mainly 4 topic is the my topic. So toxic chemical management using TRI data, mainly focus on the cleaner production and end of pipe technology. Second one is the research and development strategy. and innovation using patent data. And then third one is the relationship between economic growth and pollution. So for corporate level, I'm investigate the Porter hypothesis, and semi-macro level is the environmental Kuznets curve hypothesis. And finally, inclusive wealth and regional development. I'm using the data envelopment analysis and so on. And then related paper is I put the number here. And this is the related article. But okay, anyway. And then, I'd like to talk about the toxic chemical management study. So the objective of this study is to develop the research framework to identify the determinants that change the amount of toxicity of chemicals, focusing on the supply side and demand side. And then empirical study, the US industry sector from 1998 to 2009. And this study investigates the supply side index decomposition analysis with the demand side structural decomposition analysis to clarify the main driver of changes in the toxicity of production and consumption-based chemical emission. And this is the trend of the toxicity of emissions and the GDP US industrial sector. So from you can understand the US industry sector successfully reduced the toxic emission from 1998 to 2002. But without decreasing the industrial output. So keeping the industrial output, the gray bar, decreasing the toxic emissions, so green bar. So I think that from this result, so US industrial sector successfully reduced the toxic chemical emissions without the decreasing economic output. But from this figure, we cannot understand what is the main driver of toxicity emissions reduction. So I would like to propose the research framework using the TRI data. And this is the research framework of my research. So and then I decompose the toxicity of emission change into two factors. The first one is the demand side effect, and demand side effect can be divided two market. So US domestic market factor and then foreign market factor. So in domestic market, so domestic market demand change and also the structure change is effect. And the foreign market is the import and export scale change and then structure change is included. And on the other hand, the supply side effect is include the three components. The first one is the end of pipe treatment technology, and the second one is the cleaner production technology. So how these two technology contribute to the toxicity of emission reduction, we can clarify. And third one is the chemical toxicity effect. So this factor can capture the chemical substitution effect. So from the highly toxicity chemical to the lower toxicity chemical substitution, then this TEC will estimate that effect. Okay, and this is the equation. And then this is data source. So demand side effect, I'm using the multi-regional input-output table and WIOD. And then from the supply side data, I'm using the TRI and USBEA for the economic output data and chemical emission data. And this is the result. So this is the accumulated changes in toxicity of chemical emissions in US industry sector by driving force. So and then 1998 equal 0, the standardized, then how much the toxicity emission is decreased. Represent the line graph, show the how much the decreased, and bar chart represent the how much each driving factor contribute to change the toxicity emissions. So from this result, so we can understand the cleaner production and the end of pipe technology and then chemical substitution and the structure change contribute to reduce the toxicity emissions. On the other hand, the demand scale is expansion, so that contribute to the increase the toxicity emission. And this is the national level. And in addition to this one, we can identify the sector level result, and we can compare the how main driver of the each sector is different using this figure. So this is the accumulated change in toxicity of chemical emission of mining and transportation equipment sector. So from the this figure, we can understand the mining sector, the main driver is the cleaner production. Okay? But on the other hand, the transportation equipment sector is the chemical substitution effect is the largest one. So for the mining sector, main reason is the copper and arsenic compound were reduced due to scale down production in the US copper and the gold mining sector, respectively. So the main business was changed from the highly toxicity business to the lower toxicity business. So that reflect to this result. And on the other hand, the transportation equipment sector, so TEC, the toxicity of emitted chemical has decreased as the use of asbestos has been regulated and replaced by other chemicals. So, for example, antimony compound is the asbestos-free product, and then from this period, the asbestos emission was reduced, and the antimony compound have increased. So we can understand the main reason why transportation equipment sector the reduction successfully reduced the toxicity emission. Okay, and then finally, this is the potential collaboration research with the University of Illinois, and then I checked each researcher's research field, and then I proposed several research topic like this, and this is the related paper, and then I hope I'd like to send you this presentation material via email later. Okay, that's all my presentation. Thank you very much.
Thank you, Hide. Especially thank you for the proposal. Next is Madhu, yourself.
Yeah, sure. Let me just share my. All right. Okay. My talk is going to be about non-regulatory approaches to environmental protection and looking at effectiveness and unintended consequences. This has been a pretty long research agenda for me, and we keep chipping away at various questions that have arisen over time with this. So I'm going to present some of the general insights from previous work, and then some of the recent work that we've done in this area. Corporate social responsibility in general has been growing. We are all familiar with claims that we see in the media about companies becoming, adopting, zero emissions and closed loop processes in order to be more sustainable. And so my research has focused on trying to understand, what motivates companies to do that, to what extent these efforts are not greenwashed, they're actually effective in achieving what they are promising, and how effective are policy incentives that try to incentivize more corporate social responsibility. So efforts to incentivize corporate social responsibility have taken various forms. And in the 90s, there were a lot of government efforts in the US and in many other countries where regulators established these voluntary programs for firms to participate in and voluntarily pledge to reduce their emissions. And these programs have tried to reduce a range of emissions that have not been directly regulated, like many of the air pollutants and so on, for example, in the US. And so toxic releases, greenhouse gas emissions have not been directly regulated, and instead firms were voluntarily encouraged to reduce these emissions. Similarly, efforts at increasing energy efficiency, switching to green lighting and so on have been largely promoted through voluntary efforts. A second set of efforts have taken the form of providing information to the public. Again, in the US, this has been, as we just heard, the toxic release inventory has been a major mechanism started in the late 1980s to ask firms to voluntarily, or not voluntarily, to actually to mandate them to provide information at a very detailed level about their emissions. These are reported to the public. More recently, the Carbon Disclosure Project was started. This is a global effort at trying to get companies to voluntarily reduce their carbon emissions. And basically, the idea here is that sometimes it is where government policies are lacking, information disclosure can engage the public and stakeholders in providing incentives to firms through impacting their reputation and so on, to actually take action to improve their environmental performance. Another recent experiment or effort at trying to induce corporate social responsibility is in India, where in 2014, India became the first country to mandate that large firms spend 2% of their profits on socially responsible activities. And then in addition to the government efforts, many firms, have been leading efforts themselves by adopting various environmental management systems. Total quality environmental management system is a philosophy based on the Japanese system of total quality management and continuous improvement in quality and reducing pollution and waste. ISO 14000 is another third-party developed certification system that's completely private-led. And so we've seen a number of these initiatives that have been developed and established and have actually been successful in terms of at least getting significant participation from the relevant sectors. And so the kind of questions that I've been interested in looking at are, why do firms participate in these types of voluntary programs? Which firms are more likely to participate? How effective are these efforts in actually reducing pollution beyond levels otherwise? And what methods have these firms used to reduce? Are they actually preventing pollution? Are they doing end of pipe abatement? Are they simply shifting pollution from one media to another media, which is less visible? And then in the context of information disclosure, how does this affect firm behavior? And how does this effect differ depending upon the community characteristics that is, imposing pressure on firms to improve their performance? And then the context of the program in India that I just described, how effective was this program? Because it was a hybrid program. It set a mandate, but then it did not enforce it. And so, how effective was this as an unenforced mandate in inducing corporate social responsibility by firms? And in general, sort of a quick summary of a pretty large literature is that, not too surprisingly for economists, we do find that the effectiveness of these programs, the incentives for participation, can largely be explained by the potential potential economic benefits from it, the potential to lower costs of future regulations, to preempt the threat of future regulations, or lower the stringency of current environmental regulations and the enforcement costs and penalties that they have to pay for complying with existing regulations, improve their markets by improving reputation with green consumers, potentially lower threat of liabilities when there are, particularly with toxic releases, when there are concerns about the health impacts, environmental damages, property value impacts, and so on. And in general, from looking at a wide range of different types of environmental programs, because they come in all shapes and sizes, what has been really found effective is that when firms have numerical targets for performance that can be tracked by stakeholders, it's much easier to hold firms accountable to the pledges that they have made. And in those cases, there's greater incentive for firms to meet those pledges. When there's a credible threat of regulations, again, that leads to more effective programs. and firms that are really facing consumers and producing final goods, as opposed to firms that are more upstream and invisible to consumers, are more likely to try to improve their performance. And so, a key example of a program that was very effective in the U.S. was the 3350 voluntary program that sought to reduce these chemical emissions of some high priority toxic chemicals. Similarly, in the case of these public disclosure programs, they work because the public disclosure makes people aware that they are of facilities around them that are emitting toxic releases, and this increases the threat of liabilities for these firms. It includes there's a lot of reputational costs when the TRI is information is disclosed. It leads to headlines in the New York Times, and firms don't like to see themselves listed over there, and so they make all kinds of efforts to get themselves off the top polluter lists. Investors get concerned about it, and stock market returns decline for these firms when this information is released, and it creates incentives for voluntary participation in these programs. But the problem with the public disclosure programs is that they're limited because it's not easy to gather information, to create systems by which one can, not only obtain information, make it publicly available, and so we don't see a lot of public disclosure programs for many pollutants. Even in the case of greenhouse gas emissions, we have not been able to establish a similar a program which is as wide ranging as the TRI, and get every firm to mandatorily report their emissions. And so, corporate reporting of financial and environmental performance is another mechanism, because for, again, making stakeholders aware of what firms are doing. And a lot of firms are beginning to voluntarily report their own environmental performance as part of their annual reports. So looking very quickly at this recent work that we looked at the effectiveness of this government-led program, it was really debated in terms of how effective this would be, because on the one hand, it mandated that large firms needed to spend 2% of their annual profits on CSR activities. But on the other hand, it did not. There was no penalty if you did not do it, and so there was no enforcement to ensure compliance. And so the question was, was this act effective? Did it actually lead to additional socially responsible expenditures by these firms? And so what we use data from over 40,000 publicly traded firms in India over a 6-year period, and these, you could sort of separate out the effects between eligible firms that were required to participate and firms that were smaller and were not required to participate, and trying to control for endogeneity and all of that. What we basically found was that the eligible the act did in fact lead to an increase in reporting of these activities. Firms did spend more on their CSR, but less than the 2%. And so this line, the blue line, shows that this was the additional amount of CSR expenditures by these firms, but it was less than the orange line, which showed how the 2% relative to profits measured on the y-axis. And then using this regression discontinuity approach, we saw that in fact eligible firms, which are on the right of this red line, in fact did spend more on the CSR than the ones that were ineligible, after controlling for various other factors and so on. But what was really interesting was that we found that even in the absence of this act, firms, the large firms in particular, were spending on CSR, and that there was a strong role for peer pressure. And so firms that had peers that were spending more were more likely to spend themselves more, on CSR. And that in fact, once this mandate was imposed, then the incentives for this peer pressure induced CSR went down, because now it became commonplace. Everybody was required to do it, and you didn't get extra points by showing that you were in fact being more responsible than others. And so to that extent, the act had this unintended effect of lowering the amount of otherwise peer pressure induced CSR, and that offset some of the benefits of this act. Another sort of strain of research looking at the effects of this public disclosure, and we know that toxic releases have dropped, as was just shown by Hidemichi. But what is also interesting is that the drop has been very uneven, and in the U.S. it was much larger in the richer counties than in the poorest counties, and much more in the white communities than in African American communities. And so one of the questions we sort of want to examine is whether information disclosure has this unintended impact of worsening environmental justice, because it differs in its ability to empower citizens based on their socioeconomic characteristics. And so, we've been looking at a couple of different papers looking at how community characteristics can affect the pressure that it causes for firms to relocate. And so communities where there's much greater pressure, it can lead these toxic firms to leave those communities and move to other communities. And in doing that, there's spatial redistribution of pollution. And if these communities are locating themselves in socially disadvantaged communities, then it can actually worsen environmental justice. And so, and we do find evidence of that. We do find that facilities were more likely to relocate out of communities with higher population density, higher income, and higher educational attainment. And in particular, it was more the smaller facilities that had lower costs of relocation. But these are also facilities that grew fast, were expecting to grow, and did grow faster after they relocated, and thus their emissions increased. The other thing we found was that facilities, even if they were not currently reporting, but they there was an anticipatory effect because they, expected that there would be this pressure, and therefore they moved even before they had actually started increasing their emissions. And then just to wrap up really quickly, and facilities that relocated, particularly to low-income communities, were more likely to increase their emissions, as opposed to those that relocated to communities with a similar level of income. So for both reasons, a relocation as well as a change in their emissions after relocation, they're likely to have worsened environmental justice. And so just in conclusion, find this mixed evidence on the effectiveness of such approaches, but clearly they need to be accompanied by a credible threat of regulation and by other policies that can prevent, these unintended impacts, of these types of approaches, because these facilities can relocate, or they can crowd out other efforts that they may have taken, might have undertaken anyway in the absence of the government intervention. All right, so I will stop with that and look forward to your questions after this, and turn it over to Shunsky to present.
Thank you, Madhu. I tried to talk about the measurement for the sustainable development. So the question for the many topic, for example, the more transport, this is a increase for the physical capital. So the more the road constructed, more the easy access to the communities. The negative side might be more carbon dioxide damage to the societies. So they are both positive side and negative side. Also, if there are more toxic emissions, the negative side is clearly to the health issues, but the industrial activity is also the plus side. So my question here is, how do we actually evaluating everything get together for the whole sustainability for the region or country, or even by farm size? So we are working for the measurement for this so-called inclusive wells. I'm heading the United Nations Environmental Program Inclusive Report from the 2014. So what matters here is, first we can figure out how do we calculate the capitals, because I'm going to show later that more the total capital improve over time. We can show by proof that the sustainability for the region will be improving. On the other hand, if the measurement to be increased, the sustainability should be improved. So to calculate those asset or capital for the region or country, first, economists often use capital, but in our term, we call this is physical capitals, including the roads, building, and the machineries. And then when especially we are looking at the growth regression, such as GDP, the education matters a lot. So we can also create the human capital by more educated people get more higher income rate at time, and then the health matters too. So then the environmental economics come in to say natural resource matters, such as oil or coal or agriculture. So the more the abundance in the natures, they can help utilize better resource so that they can be the complement to the human capital to improve the quality of the market. So all these can be added together in the monetary terms. And in the Steve Prusky's summary for the PNAs, it is showing that this inclusive wealth is a measurement for understanding the sustainability by summing up all these capitals. This should be the sufficient statistics showing we are on the right track or not. In our different paper in the science, we argue this should be the good measure for identifying and keep track for the United Nations Sustainable Development Goals. So the bunch of the theory papers in the past, such as Ken Arrow and Pasa Dasgupta, have been working to prove the increase of the inclusive wealth should be the guaranteed one for the sustainability in the countries. So there are lots of news media got attentions, including the current United Kingdom's Dasgupta review for the conserving the natural resource and the biodiversities, showing that not just for the UNEP's report for showing this inclusive wealth to be important, but even the each country level, they try to identify this to be increased as a nation's target. And always, in the most of the countries' case, produce capital or human capital is increased in many years. But the natural capital is almost always decreasing. One reason is use up the more resource such as oil or other minerals. Also the deteriorating the forestry and the other ecosystem service. So to sum up those accounting metrics, what we have been and also the colleagues in the United Nations has been working is economics counting method, diverting from the usual cost counting for the GDP into the more system of national account called the SNA from the 1980s later time. And the idea is nature to be more important, then putting those value in the monetary term to be appendix with the GDP metrics. Then try to show the green GDP matters and the growth of the green issues matters. So the idea here is if we are complementing the natural capital by decreasing natural capital by other physical or human capital, that would be okay. And this is called the weak sustainability. And the strong sustainability says the natural capital itself shouldn't be decreased. And the economists and also our approach says weak sustainability to be matter. And the theoretical background is provide this, Dasgupta and Arrow and Mayrers. So what to be counted by nations and also region is matched well in the many of the statistics. And this can be disintegrated to the each city or county level too. And what we are proposing and also the many statistics used in the region is more focused on the natural capitals, because for the produce capital, these are already available for the many countries. And then for the human capitals, education's value and the health value is calculated from the education economists and also the help from the health economists. Then our focus is also the natural capitals. And the missing part is non-well studies topics such as coral reef or mangrove or many other biodiversity related. So even though we capture some kind of non-timber forest resources as a kind of environmental value, but still many things should be added over times. And as I said, in the many of the case in the global level, also many countries follow this trend on the left-hand side. So the natural capital tend to be decreased over times. And we are updating the data up to the 2018 now. And the trend is also same. So more the carbon emission increase, that means the value for the increased wells to be decreased. And the more the produced capital is associated with a natural capital decrease. So those are kind of common statistics. Then on the right-hand side, we try to put the past statistics, also the future simulation showing more the energy use is associated with the higher GDP, which is good. And also the higher GDP is often connected to the more physical capital. That's why increased wells to be good. But their best mix combination for the some percentage of renewables in the energy usage would be good for the increased wells perspective. Same as not overuse of the resource would be good. So again, there are some threshold for the GDP to be connected well to the higher increased wells. So we can aim for long run higher growth for the increased wells should be matched with certain energy mix combination as well as relatively increase of the GDP, but not the sudden jump for the GDPs. This is my final slide. We are now combining those national and regional statistics, even for the satellite and the land use data for the regional levels. Then that can be matched to the individual survey for the many countries, which account for the 37 major countries on the global. Try to identify how those regional abundance on the resource or also the scarcity of resources are associated with better wells for the increased wells. And maybe that can be attached to the more higher happiness or life satisfactions. And we are trying to identify some kind of policy matters in the regional level as well as global. And those kind of past statistics, also the future simulation might be more implication for the policy issues in the IPCC or IP-based kind of United Nations activity. Then trying to also analyze for the industry analysis or farm analysis. So maybe that's kind of be the topic for the future collaboration. Thank you.
Thanks, Shinsky. All right, our last but not least speaker is Professor Amy Ando from the Department of Ag and Consumer Economics at Illinois. Amy?
Okay, can you hear me? Can you see my slides? Last but not least, let's see. There. Well, thank you all for staying to the end. It's really a pleasure to be joining this excellent group of people in this really fun symposium. So I've got research on a lot of different things. I thought for this event, I would give you an overview of some of my research on environmental valuation, specifically exploring patterns of variation in environmental valuation. There is a huge literature on non-market valuation, both of environmental things, also food, energy, lots of different things. In the United States, in environmental economics, research on environmental valuation, I think, is really dominated by a couple of specific demands for non-market valuation, and that is in general accurate total benefit estimates. We need those in our government for cost benefit analyses for all of our major environmental regulations. So there's a lot of research about the value of clean air, clean water, climate stability. We also use environmental valuation for damage assessment for liability. So you may have heard of these really huge cases of the BP's oil derrick exploding and spilling oil all over the place. In order to support those billion-dollar liability cases, we need estimates of total damages. Those are important uses, but as a result, a lot of the research has been kind of limited. There are many important things related to the environment and natural resources that haven't really been valued. And we don't have that much information about the ways in which values vary across people. So I'm going to give you a little overview of a few of my papers on environmental valuation. A paper on urban beaches, where there's no research on this, at least in the United States, and who benefits the most. A little paper about people's willingness to pay for an agreement for their home to be bought out if it is destroyed in a hurricane and a flood. This was an untested policy proposal, and so we used valuation methods to see how much people would value this and how uptake could be encouraged. And then I'll end with a paper in the works about grassland restoration. Grasslands in the United States are important habitats, but very little studied. What I'll show you is paper number 2 in ever. But here we're looking at heterogeneity and asking, to what extent does childhood experience shape adult preferences over environmental goods once they're all grown up? And I'll end with a couple examples of questions that we might answer together. Okay. So to begin, I'm going to take you to Chicago. We are not in Chicago, but that's a picture of Chicago. And Chicago is a great big city, not as big as Tokyo, actually not as big as a number of Japanese cities, but it's pretty big. And it does have these beaches that are free and open to the public. So my student Claire Munaretto and I did a paper. We were interested in the extent to which willingness to pay for urban beaches varied among racial and ethnic groups. So Professor Khanna mentioned this concept of environmental justice. The United States is a very diverse country with a lot of big inequities between people in different racial and ethnic groups. And so many of us are asking more of these questions. Who is reaping the benefits of the environmental goods that we provide? And then are urban beaches normal goods in the technical sense? Are these things that people demand more of as they get wealthier, or are they inferior goods where we mostly see low-income people taking advantage of them? So Claire did a travel cost survey. She surveyed people all throughout the Chicago area in about right after the summer season ended in 2016 to find out where they lived, did they have cars, could they swim, what was their income and race, and so on and so forth, and how many trips did they make to these beaches along the coast of Chicago. That coast, by the way, is Lake Michigan, although if you stand there and look out, you can't tell it's not an ocean. It is so big. And so then in the standard travel cost methodology, she analyzed the trips as a function of the travel cost for that individual, controlling for their race and income and other factors. And so we're controlling for how close people live to those beaches and for whether or not they could swim, because in the United States, there are racial differences in who has learned how to swim, and we wanted to make sure that didn't confound things. So we found a lot of numbers. Just to zoom in a little bit, if you look at income, the largest values of willingness to pay and consumer surplus from these beaches was actually in quite low income households. And the largest value was actually in Black households. In contrast, the lowest value for income categories was in the wealthiest households and in white households. So what we're finding is the average willingness to pay is quite large. In fact, total value of these beaches is bigger than the cost of maintenance. So that's good news for the city of Chicago. And willingness to pay does show this variation between groups. So this is good because it helps the city managers to be sure that their investments are serving those city residents most in need. Part of the context for that is that in our country, we have a long social history of Black Americans being excluded quite violently from public swimming opportunities. And so making sure that these are available and valued now makes up for the fact that they're still excluded from private swimming opportunities. Okay, something totally different. This isn't really about an environmental good, but this is a paper my student Colin Reeser and I just had accepted at Land Economics that has to do with floods. Or it could be about other kinds of natural disasters. But as we all know, climate change is happening, actually more daylight floods, but also more extreme storms and so on and so forth, destroying homes. We have a problem in the United States where we have federal flood insurance and it was being overwhelmed by the number of people whose houses got wrecked, but then they rebuilt in place. And so there was still that property exposed to damage. So there was interest in the government and in a nonprofit about would people be willing to sign an agreement that said, you know what, I'm going to agree right now that if my house is destroyed, I will let the government buy me out. But then they have to promise that they would be bought out and leave. And so we didn't know, would people be willing to do that? Or would they be sad about losing the ability to live where they had lived and need to be compensated? And who's most likely to be willing to be bought out? So we did a contingent valuation survey across the whole country, eliciting people's willingness to pay for this kind of pre-flood agreement. And we were shocked. We found that pretty much everybody is like, yeah, I'll pay for that. I'm in a flood zone, tired of my house getting wrecked. I will pay the government to give me this contract. Average willingness to pay was $600. Almost everybody had some positive value. But even more interesting is who has the highest willingness to pay. So of course, rich people want to pay more because they're rich, but people who estimated their flood risk was high had a high willingness to pay. And if they'd had flood insurance claims, they're like, yes, take my house. But also people who thought that most of their neighbors were going to move anyways were more likely, were willing to pay more to also get out. And so that's really interesting information, not just, you know, helping policymakers know that this policy might work, but also thinking about how to harness community effects to implement effectively. And then finally, I'll kind of run through this one, work in progress right now with another graduate student. How does childhood experience with nature affect adult willingness to pay for, in this case, grassland restoration? So Illinois used to be all grassland. It's mostly gone, but a lot of people are restoring it. And so Li Ching was asking whether if kids did stuff like this as little kids, are they more likely to be willing to pay for restoration of grasslands when they're grown up? So she did a choice experiment survey. I noticed a couple of you have done that, and found that in fact, active childhood experience with camping and environmental education increases willingness to pay positively, and having negative experiences as a little kid, you know, you got poison ivy or stung by bees or whatever, makes you less likely to makes you willing to pay less for nature restoration as an adult. But even passive stuff, just living within 20 minutes of a grassland as a kid had a pretty big positive effect on willingness to pay. So when we did this in a latent class model, class 2 is the high childhood experience group. They're willing to pay, you know, for the gold standard, 30 bird species, 3-mile trails, all the fishing and camping you want, $177 per household per year, whereas the other people who didn't have high childhood experience are only willing to pay $29 a year. So that's really interesting. If you're a person who's interested in halting erosion of demand for nature, environmental education might actually be useful. And understanding the value that people have on different recreational attributes helps managers know how to restore the grasslands they're working on. So in conclusion, people can have pretty high values for these understudied elements of nature and the environment. And while I also do revealed preference research, stated preference research can be helpful when you're trying to scope out the viability of a policy that has never existed. So you can at least take a stab at it. And I think that there's a lot of interesting stuff to be done looking at how values vary among people. So possible future work. Alex, I was thinking thinking of proximity as not just where you live. You know, could it be viewshed? For example, you were looking at solar close by, but it could also be solar where you can see, or where you work, or related to your commute. I was also thinking, listening to the earlier talks about consumer preferences for electric cars, how does that depend on home ownership and access to charging infrastructure? This could also end up being an environmental justice issue, at least in the United States, where there's a big difference between people who have homes and garages and people who don't. And I would look forward to exploring other ideas of mutual interest. And I do look forward to collaborating with you, hopefully in person, either here on the left in Urbana or there on the right. Now, that's actually a photograph I took in the mountains west of Tokyo. Perhaps someday I'll be able to put a picture of the area around Kyushu instead.
Thanks, Amy, for ending on that positive note. That's something we all look forward to, being back in person and not confined to our rooms with Zoom. So we are almost at the end of our time here. But if somebody has a quick question for the last 4 speakers, you know, we can take just a couple minutes maybe to answer one question. I know people have been asking them in the chat, so if you do have a question, just feel free to unmute yourself and ask. If not, you know, I think that this was really productive, and it was great to see a lot of synergies in the work that we are doing here and the interests that are there, you know, at Kyushu. Clearly, you know, we need many more such conversations in order to be able to identify some opportunities for further collaboration. But I think we've got fertile ground here to begin that process. And you know, I would suggest that we, you know, plan on a future meeting, maybe in a smaller group and a little bit longer time to think about, you know, delving into some questions that might be of interest. Let me see if any of our other speakers have thoughts on what next steps they would like to see.
Thank you, Madhu. This was a great opportunity. The evening time to you and our early morning time also match well, and hope to talk online, and you know, always wishing for the physical meeting. But some topics that's raising the transportation issue, some of the developing country issues, or land use issue for the solar, and some other willingness to pay. I think those several topics probably match well, because in the 8 speaker talk different topics, different techniques, and different regional categories. So hoping to more, you know, finding the small group to identify the mutual interest and go on for the next step. But thank you for all these 2 hours event. Thank you.
Thanks, Shinsuke. Any other thoughts from our other speakers? You know, maybe jumping just a little bit ahead, and just wanted to let you know that, you know, one of the events that our center does organize every year is a Heartland Environmental Resource Economics Conference. Amy has been leading that the organization of that conference for many years now, and I believe we have the next one planned for, I think it's end of September. Perhaps you can be more specific about that. And we welcome, that basically brings environmental economists from across, definitely across the country, but we often have participants from outside. And if we are indeed, still doing things on Zoom, which I anticipate in September, at least for international visitors, will be on Zoom. That would be a great opportunity to have participants from Kyushu. So maybe just quickly, if Amy, if you want to take just a minute to speak about the Heartland.
Yeah, I will. Sorry, I wasn't prepared to talk about it, and so I would have to look up the dates. That's okay. I actually think we moved it to October for various scheduling reasons, which is good because it's longer for COVID to go away. I'm pretty sure that we will end up being at least partially hybrid, so that some people will be here in person, but other people would be able to participate from far away. So I'm happy to, perhaps we can set up some kind of email listserv amongst the researchers in this group, and then we can kind of communicate with each other about, and I'll share that information with all of you.
Yeah. We'll figure out a way to set up that listserv so that we can communicate more easily. Yeah.
I mean, in terms of next steps, I just think there's a lot of talking to be done, and that's hard to do in this formal structured thing was great, but I look forward to a less formal, less structured interaction.
All right. So not to delay people much further, I'd like to now turn it over to Dr. Ritu Mabokela, who's the Vice Provost for International Affairs and Global Strategies at the University of Illinois, to give some closing remarks.
Good evening, colleagues here at Illinois, and good morning to our colleagues at in Kyushu. It's really been wonderful being a part of this conversation. The set of colloquia and workshops that we've had since the beginning of this semester, this is our third one, have truly been invigorating and connected colleagues in ways that we hope will continue to build on the relationship that our two institutions have had really since we started working together through ISNO over the last decade. And we're just truly delighted that this conversation tonight around environmental economics brought together yet another set of colleagues across our two campuses to explore opportunities for mutual engagement. I should really applaud all of the faculty members and our two leaders, Professors Hana and Manaji, who put together this workshop for tonight, for really braving this global pandemic and adjusting their approach to research engagement and many other aspects of our work in the midst of this pandemic. And more than anything else, for pursuing and exploring opportunities for collaborative research excellence. And of course, to really echo what Professor Ando said, we hope that we will be able to engage in person in the hopefully not too distant future when it is safe to do so. But I truly do applaud all of you for leveraging this opportunity to build a strong foundation for what we know will be a sustainable and mutually beneficial relationship. So thank you again for taking the time to join the colleagues in this conversation for the last couple of hours. We look forward to continuing these conversations. And really from the international office, our role was to facilitate the meetings and the greetings. And now that you have met, greeted, and we will stay out of the way and facilitate what we know will be exciting research opportunities. Thank you again for our facilitators and our collaborators. And we look forward to continuing to support your efforts from behind the scenes. Have a good morning in Kyushu and have a good evening here in Champaign-Urbana. Good night.
Thanks, Ritu. Thanks very much for your support and for facilitating this. Doing international collaborations is not easy, and so we certainly really welcome the support that I got, and I want to acknowledge support that was provided by your office, by Samar Jones and by Shuo Wang in making this possible. So thank you very much, and really look forward to our continuing this conversation with our Kyushu colleagues. And thanks, Shunsky, for helping to put this together. And we will be in touch and to discuss next steps as we go forward.
Thank you, Madhu. Thank you also for our international collaboration team for the Suenaga and Professor Kono on this, and hope to individually talk each other by email and a smaller group. Thank you very much.
Okay.
Good evening and good morning.
Good night.
Good night.
Thanks,
Bye-bye.
everybody. Have a good night, good day.
Bye-bye.
Bye.
Bye.